all is targeted at formative assessment, although for the purpose of evaluation we have evaluated it as summative assessment, the results of which I will be talking in a moment. So for example, for the select recipe label, so if the label in the model solution is select recipe, one of the positive feedbacks, I mean, I have just made them from my mind, but the lecturers can tailor it, of course. Positive feedback could be, good, you have selected a recipe, now you should do something else. The negative feedback could be, you are missing something, think about the first thing you should do before you decide to eat at home. So as to point them to the right direction. And then there's a marks and order index. Order index I just have introduced yesterday, and what that really means is when the students get the feedback, in which order they should get the feedback. Maybe one label is more important than the other label, so the lecturer can decide which order they should get the feedback in. This is the tool that we have developed at Brunel for this project. We have not enhanced the GUI too much, so it's very naive in terms of the GUI as such. So the first field is the model solution, which has been drawn by the lecturer. So we give the file path of the model solution. Of course, later on we will be putting a browse button and all that. The second field is the student's answer file. So of course, in a real life scenario, we will probably hide this, so that the students just needs to upload their diagram, and then they press the automatic mark button and they get the feedback, which should look something like this. So this is the a test diagram that I have drawn to demonstrate the tool. So the student get the feedback like this. So they get for every state which is correct, they get the positive feedback. For every state that is incorrect, they get the negative feedback, and in the end they get kind of indication of marks, that how much they have got. This of course can be used for summative assessment because it gives the marks, but I think it's more suited for formative assessment so that the student can get the feedback and improve upon. Okay, now we'll talk about the evaluation bit, that how did we evaluate this software at a coursework at Brunel, and this is the summative for summative assessment. It's from module CS1022, in which students need to diagram UML models. It was an in-class paper-based test. Students had drawn the diagram not using the tool as we would have wished them to, but instead they draw it on a piece of paper. I'll just show you how it looks. And then we manually, I scanned all the coursework, all the 189 course paper of the students, and then I manually extracted the labels from each coursework. Just to say that we didn't have any interference in the test. So all this was carried out after the test. So the test was in perfect natural scenario, and once the test was over, marking was done. That's the point wherein we collected the data for the evaluation. This is the text that the students have got for this evaluation. So the student needed to draw an activity diagram for a scenario, which is this. This is what the model solution looks like. So it has kind of some labels and some states, and this has been drawn by the lecturer. For the purpose of evaluation, we have not taken into account the possibility of multiple solutions being correct, although that can be an enhancement. But for the purpose of this evaluation, we are considering that this is the only correct solution for this scenario. This is how a student's diagram looks. So this is one of the diagrams from the students, and these are the marks given by the lecturer. We evaluated it on 189 students' courseworks, and these are the statuses for that. This row is for the machine marks. So on an average, the machine is giving 3.16 marks, and these are marks out of 5. So on an average, machine is giving 3.16, but the human marks are 3.02. So it seems the machine is more generous than the human marker. About the difference between the machine and the human marks, on an average, the difference between the machine mark and the human mark is 0.74 out of 5 marks, which is roughly 14%. So 14% is the difference between, on an average, the marks given by the human and the marks given by the machine. The range is same in both the cases. About the standard deviation, I was a little bit puzzled by this standard deviation, but I'll just explain what it is. The standard deviation for the human marks is 0.94, while the standard deviation for the machine mark is 1.35, which tends to suggest that humans are more consistent, because on an average, the standard deviation is 0.94, whereas a machine marks is fluctuating a lot. I'm not entirely sure why this happens, but yeah, this is just one of the comments. But the standard deviation, or the difference in the marks, is 0.88, which is just okay. Then I found the correlation between the human marks and the machine marks, and the value of the correlation is 0.72, and it's statistically significant, which tends to suggest that there's a high degree of correlation, positive correlation between the human mark and the machine mark, meaning if the machine marks them, if the human mark gives them a more marks, machine too gives them a more marks, and vice versa. Okay, now this slide explains these are the difference in the marks between the machine and the human. So 0.00 means there's no difference between the human mark and the machine mark. 2.5 means the difference between the machine mark and the human mark is 2.5. Now, as you can see from here, 30 students' coursework had zero difference. It means 30 students' coursework out of 189 had exactly the same marks as was given to them by the human, which is roughly 15%, almost 16% of the students had the same marks as given to them by the human. Another interesting figure is 45 students. So almost 23.8% of the students had a difference of just 0.5 marks out of 5, which means 10% deviation. So it means almost 24% of the students were in the range of 10% of the marks that was given to them by the human. The other big number is 41, which is almost 22%. So it means 22% of the students, or 41 students out of 189, had a difference of 1 marks from the human, from the marks that were given to them by the human. Yes. Now, and the biggest difference is 2.5, but just 4 students had got a difference of 2.5 marks. Now, since in an ideal scenario we would have wished 189 to be here, meaning the marks should have been exactly same to that of human, which is not the case here. But I think this seeing high frequency 30, 45, 41, which seems to suggest that there is a kind of good relation between similarity between the marks given by the human and those given by the machine, and hence it possibly can be used, if not for summative assessment, then certainly for formative assessment, so that